So thanks for joining us. Today we will be discussing how to protect your internet-facing applications hosted on AWS. Today I'm joined with my esteemed colleague, Tom. Would you like to introduce yourself?
Hi folks, I'm Tom. I'm a principal solution architect focusing on networking.
Great. And by way of introduction, I'm Moon Hussain, been with AWS for a couple of years, and I'm in product management in the security division. So we've got a packed agenda. What we will start off doing is defining the scope or the attack surface in terms of the typical internet-facing app that we'll be referencing throughout our presentation. And then we'll talk about the problem statement in terms of the anatomy of a multi-vector threat that typically targets these internet-facing applications. Then we're going to do something really fun where I will pose as a bad actor, Tom will be a defender, and then we will incrementally sort of raise the bar on the attacks while Tom iteratively raises the bar on the defense mechanisms to protect from those attacks. And then we will follow this up with best practices on inserting AWS WAF in particular for protecting against internet-facing apps. But not everybody has internet-facing apps, not everybody has HTTP apps, so we'll also talk about the scenario where we have non-HTTPS applications as well. So I'm going to start off with an eye chart. Not all of our slides will be this confusing, but just to sort of decipher what you see on this slide, you'll see the networking elements to the bottom of the slides, and you'll see the security elements to protect the network towards the top of the slides. And this is a typical scenario where customers typically start off with the identification portion, where they map their network services. They use services like Security Hub to map the services relative to the type of posture that they would like to achieve based on their compliance needs, after which they deploy security services to protect their environment. The security services that we will be most focused on are the ones in the yellow boxes. AWS Shield, looking at anomalies in traffic profiles and protecting from L3, L4 types of DDoS attacks. AWS Network Firewall, that has embedded IDS, IPS capabilities to complement the firewall capabilities for inspecting from layer 3 all the way to L7. AWS WAF, which we'll be most focused on in this session, as well as something that brings all of these services together under the umbrella of AWS Firewall Manager from that whole cross-organizational management perspective. Once these security services are deployed, you then want to detect. And you do some detection in the services itself and some mitigation in the services, but the detection that I'm referring to on this slide is much of that broader SIM kind of analysis where you can utilize things like Amazon Guard Duty or Amazon or AWS Security Hub to do some of that detection. There's the automation and investigation, after which you respond, followed by the recovery phase. So what I'm going to do now is describe that attack surface in terms of defining for you the sample internet-facing app. Now, this is pretty self-explanatory. On the left, you have the internet. On the right, you have the AWS regions, within which you have the availability zones over here, A and B. We've got the VPCs deployed inside the availability zones, and within the VPCs, we've got the public subnets as well as the private subnets. Now, typically, when you have the application tier or the web tier, you'll want them in a private subnet for confidentiality reasons, but they're typically communicating with back-end web servers where they can retrieve information, write information, so on and so forth. Now, in order for the applications to speak to the outside world, they'll need a way to get out there in terms of the traffic going back and forth, and then you have an application load balancer that provides that level of connectivity. The application load balancer is represented with elastic network interfaces, which then connect to external elastic IP addresses that it communicates in through the internet gateway on. So if you look at a packet flow, typically what you'll do is when a user wants to access a certain type of application, they'll do a DNS lookup. So that happens by passing traffic to the Elastic IP addresses, which then communicates through the Elastic network interfaces to the application load balancer. And one of the key capabilities of the application load balancer here is to also terminate TLS connections from that encrypted traffic. Once that is done, the traffic then passes on to the application layer where you have the web servers, which then also communicate back with the back-end databases. Now, for simplicity, for the purposes of what we will be discussing, we're going to eliminate all of the back-end stuff that we just talked about and focus more on the front-end stuff with application load balancer working in conjunction with things like Amazon CloudFront to make the application servers that much more performant in terms of scalability, resiliency, providing CDN capabilities through caching and things like that. We will also deal with non-HTTP traffic. So instead of the application load balancer in this case, we will show you instances where we will replace that with a network load balancer, which looks at all ports, all protocols, UDP, TCP, and works in conjunction with the AWS Global Accelerator. And what the Global Accelerator does is provide sort of a global view and some load balancing, and also allows customers to utilize the AWS backbone as opposed to being exposed to some of the unpredictable nature of a DIA connection or a direct internet access connection. Additionally, just closing off on this, very analogous to the scenario where you have VPCs in the availability zones, we will also talk about serverless instances where you sort of replace the VPCs and you have serverless entities like API Gateway, AWS Lambda, and DynamoDB also working with CloudFront. So hopefully this gives you a good idea of the sample application that we will be talking about in the latter part of this presentation. But before I begin and we put on the bad actor hat and the defender hat, let's just talk about the roles, how we define sort of the bad actor and the defender. So the defender is interested in CIA, confidentiality, integrity, and availability. They want availability of their systems at all times. They want to make sure that internal resources are not stolen and sold to the dark web. And they also want to align all of these practices with their compliance needs as well. It could be a general compliance need with NIST, or it could be very vertical specific related to PCI compliance or HIPAA compliance in healthcare, for example. The bad actor, on the other hand, pretty self-explanatory, wants to reverse engineering the goals of the defender, which is to gain unauthorized access, to disrupt operations, steal data, and the key driver here is usually financial gain, especially in this case, as we'll exemplify in a moment. So those are the intents. Now I'm going to talk about the problem statement. So you've got your internet-facing app. So what is it that we need to protect from? So the typical issues that customers go through are the deals regarding multi-vector threats. So multi-vector threat can be viewed as a threat that has multiple components, and in order to detect and protect in all of these components, you cannot have a siloed view on any component of that multi-vector threat. Rather, you have to look at the entire time continuum of how that threat occurred and look at it in the context of other pieces within that threat. A simple example is ransomware. So we have to have all of the pieces working collaboratively to ensure that there can be sort of a coordinated way in which the threat is detected as well as remediated. So an example of this would be something similar to a ransomware, where initially there are reconnaissance activities that take place that deals with the rattling of the doorknobs just to find out what types of services are running, followed by backdoor access to the network, followed by the actual infection with malware. All of these first three components are part of that ingress chain, and then you go into egress, where you can open up command and control channels to speak to the outside world and have control of certain systems internally. And then the last piece is the east-west directional infection, where you want to perform lateral inspection, expand the blast radius as much as you can, as effectively as you can, to sort of propagate the threat elsewhere. Now, if you look at the typical detection capabilities and remediation capabilities, they're vast. When we talk to CISOs, they tell us that they have anywhere between 20 to 50 security vendors in their network. So similarly, as you can see over here, the key takeaway is that there's no one single silver bullet that has the ability to detect and mitigate or remediate all of the components of this multi-vector threat. All right, so now we will get into our bad actor mode. So I'm the bad actor, Tom is the defender. So the very first thing that I want to do is partake in reconnaissance activity. Typically what I'm going to do is I have a strategy of figure out what's out there and then get my attacks successively more constrained in terms of how surgical they are and how sophisticated they are. So I'll start off with a sort of a spray and pray technique and then get very refined as we go along. So the first thing that I want to do is discover the types of applications running. So in order to do that, I will have to do things like a ping sweep or a port scan, an ICMP ping or TCP SYNs that I will send, and then that will gather information of what services are running, what ports are open, and how these services map to the applications that I'm targeting.
All right, thank you, Moon. And thank you for agreeing to be the bad guy, letting me be the good guy. I see you even dressed the part. So my job is pretty easy because, first of all, our application is HTTP, HTTPS. So let's say it's HTTPS. We are listening on port 443 on our application load balancer. So immediately, all the other connections, ICMP, TCP connections on different ports, would immediately get dropped. So that narrows down that reconnaissance scan purely to port 443, because that's the only thing that we will respond on. If we want to narrow it down even further, we can deploy security groups or network access control lists around our resources in the VPC. And here's an example of a security group where I'm blocking traffic or restricting traffic to only a specific source IP address range. Now, we do realize that if you have a public-facing application, that's not always possible. You might not know exactly what IP addresses your users are going to come in from. So if that's the case, you can also, so that will narrow it down, but if that's the case, you can also deploy AWS WAF on top of your application load balancer. So AWS WAF is a fully managed web application firewall that allows you to craft rules and deploy them on different AWS managed resources that receive HTTP, HTTPS traffic. It's very easy to enable, so it becomes effectively, from an administrator point of view, a part of application load balancer. So you don't have to set up special routing rules. Application load balancer already terminates TLS, so WAF will get access to unencrypted traffic to be able to perform whatever controls you need. So in the case of ALB, you just enable it with a single option or a single API call, either where you're creating the application load balancer or for an existing one. So what are the rules that we would be configuring on WAF? So we can also set up IP-based rules, but just like we discussed, we might not know exactly what IP addresses our users are going to come from, but we can also set up geo-based blocking. So in this scenario, we can, an example I'm showing you, we're saying that we're allowing traffic if it comes from United States. So that means that maybe all of our user base we know is in US, and we don't expect traffic from any other locations. And we can block that traffic, we can allow that traffic and block any other locations connecting to our load balancer. We can also use AWS managed rules or third-party managed rules, where we will have a managed set of rules with potentially malicious source IP addresses. So we already know those IP addresses, and you can block them automatically by adding those managed rules into your web application firewall configuration. So with all of that put together, we're really narrowing down to just a small subset of allowed requests to our application load balancer. And maybe we're even potentially able to completely restrict access from malicious sources.
All right, so little frustrated that my reconnaissance didn't work the intended way. So now what I'm going to do is flood the network. I'm going to flood the pipes. So there are different types of DDoS attacks. This was going to be volumetric in nature. So I'm going to do a UDP flood. So I have a bunch of reflectors or request filters and amplifiers. And essentially I'm going to flood the network with UDP traffic with the intent of ensuring that legitimate traffic cannot get through, which is not a very big deal in a cloud scenario where you've got a lot of resources, but in the case of an on-prem scenario, this can be disastrous in terms of not being able to manage the pipes accordingly to, stop the bad traffic and let the good traffic in.
So I like that you're trying harder, Moon. So what can I do? So the first good news is that situation with the on-premise pipe being saturated is not going to happen if you're in the cloud. We have terabits of transit and peering capacity in all of our regions that's constantly being scaled up. So there's a lot of capacity and virtually impossible to saturate. The second thing that we will benefit from is AWS Shield. And I'll talk what AWS Shield is, but the standard Shield offering will automatically kick in for any public-facing resources that you deploy in AWS. So it's an automatic protection and mitigation from DDoS attack against the infrastructure and your applications. So if we deploy Shield, or if we have resources inside of the region, Shield standard would usually take care of 99% of volumetric attacks within 1 minute. The remaining 1% could take up to 20 minutes. And then with deployment of content delivery networks, so if we were to use CDN, CloudFront, that 99% infrastructure attack mitigation goes down to 1 second. So what is Shield? Shield, fully managed DDoS protection, and it comes in 2 flavors. The Shield Standard, that's the default, automatically running in every region. And then Shield Advanced, which are additional capabilities that you can add to the standard offering. So if we look at Shield Standard, it provides a layer 3 and layer 4 protection to your infrastructure that lives on AWS, and that's pretty much it. But it is a free service, and all you need to do is just deploy public-facing resources in AWS region. With Shield Advanced, you're getting all these additional benefits. I'm not going to list them all out. But know that there is a cost associated with getting Shield Advanced. So your protections extend from layer 3, layer 4, all the way to layer 7 with the help of AWS WAF. You get the ability to start seeing those attacks in your monitoring tools to actually see which resources are under attack. You get access to 24/7 DDoS response team, so AWS experts that can help you craft mitigations, both at layer 4 as well as layer 7 within your WAF configuration. You can even set up automatic mitigations within WAF, and then you get access to cost protection. So deploying Shield or Shield Advanced is not enough. You still need to deploy your architecture in a way that it's able to accommodate the initial spike of traffic. So if you need to scale to accommodate that, you're going to be able to recover some of those costs if you're using Shield Advanced.
All right. So he was able to stop the volumetric attacks. So I need to be a little more surgical, still after going after the availability of the applications. But this time it's going to be an L7 DDoS attack where I use HTTP requests using HTTP request amplifiers and direct them towards the CloudFront edge locations all the way up to the application load balancer. And the intent over here is to inundate the applications with multiple requests so legitimate requests cannot get through.
Yeah, so you're definitely making it harder for me, because with this particular attack, the request might actually look like legitimate traffic. So it's getting harder and harder to distinguish what is the real traffic and what is the malicious traffic that we're trying to get rid of. So to help with that, we will also use AWS WAF, but this time we'll deploy AWS WAF on CloudFront, so on our content delivery network. Just like with Application Load Balancer, it's very simple to deploy. Single tick box or single API call, and you have a web application firewall running on your CloudFront deployment. which will allow you to limit those requests and identify malicious traffic and drop it. But then we can look at some of the rules that we need to configure to be able to do that. So the first rule we can configure is a rate limiting configuration. So with this example here, I'm setting up a rate limit, so I'm analyzing the incoming requests. And if I see within a 1 minute period more than 100 requests from the same source IP address, I will want to block that IP address. And I can use other identifying criteria, so maybe information in the IP address in the header or some custom keys. But either way, if I see traffic breaching my rate limiting configuration, I can then take an action. And there's a number of actions here, and we'll dive into each one a little bit deeper in a second. But we can either take one of those actions, or we can allow traffic and label it to process it further down the line. Okay, let's talk a little bit about the actions that WAF allows you to apply. So allow, pretty self-explanatory. I'm not going to talk about that one. Block, also pretty simple. You're just blocking the traffic. But you have the option to modify what response code you're returning to the client that's blocked, or even what is the custom response in the body. Count is something that many customers use when they start initially their journey with AWS WAF, and they want to see what's happening, and they often export the data as well as logs into analytics tools to see what's going on, what traffic's coming through, and what would have been blocked if any other rules were enabled. And then we have two interesting rules at the bottom, challenge and captcha. And they're used to identify or validate the actual client connecting to our application. So with challenge, we're not having the actual user involved, just the client application. We're sending a piece of code, or effectively a challenge, a computational challenge to the client application, expecting the application to resolve that challenge and return the response to us. So if the application will not do it, it's likely a bot, or it's likely an application that's not a real user, and traffic will get dropped, or we can take another action with that traffic. And then captcha is, you've all probably seen captcha before. It's when the human is involved and they have to resolve a challenge to validate that they're not a robot. We also have the capabilities and predefined rule sets to help you with identifying bots. So these might not exactly be the best idea if you're purely focusing on DDoS, because that volume of traffic could come at a cost. But if it's a smaller number of requests that are potentially malicious and you're expecting those requests to be coming in from botnets, we have a set of managed rules that can help you identify those bots. So we have a set of rule sets that allow you to identify the common bots, like the web scrapers or search engines, that typically identify themselves as bots. I'm not showing you those. The targeted rule sets are focusing on bots that are trying to hide from us, are trying to pretend they're an actual user connecting to our application and doing something malicious. There's a number of different rule sets within this managed rule for bot control. I want to focus on three very quickly. The first one would be looking for tokens in the request. So you can use a piece of JavaScript, a little SDK, add it to your application, and then whenever your real client connects, they would come in with a token in the cookie, and then WAF could identify the token and identify that this is a legitimate user, regardless of the IP address that traffic is coming from. And then in this scenario, we'll be looking at those challenges. If they're missing, we can take an action. In this example, we can challenge the user again, but we could also block or do something else with that traffic. Now, for botnets that are a little bit more complicated, we can use some machine learning. So it's an option you can enable in AWS WAF to use machine learning to try and identify with different levels of confidence, medium or high, if the behavior we're seeing is potentially a botnet or not. And then again, take an action. In this example, I'm just counting. So I'm labeling the traffic and doing something else with it later on. But you can set all those rules to immediately block if that's what you want to do. So dealing with bots in general can be a little bit complicated. And as bots get more advanced and more sophisticated, your approach to dealing with those bots has to be more advanced and sophisticated. So at the bottom, the simplest thing to identify bots based on would be IP address, or maybe bots that are actually identifying themselves. And as they become more advanced, you have to apply different rules. So actually start looking at things like the tokens we talked about, or even further up the stack, start using machine learning algorithms to identify traffic patterns to figure out that, hey, these are bots connecting to my application.
All right. So I've looked at the availability of the bandwidth. That didn't work. I targeted the availability of the web servers. That didn't work based on the L7 attack. Now I'm going to target the availability of the back-end databases that the web servers are connected to. Now, to my benefit, a lot of the applications out there are poorly coded, meaning that there is insufficient schema validation. So when a URL argument is passed, the attacker, myself, has the ability to insert a malicious string. In this case, my malicious string is drop.database with the intent of putting the database offline. And this will be passed through the web server as the web server communicates with the database itself, and then it will generate the availability of, taking that database offline for lack of connectivity between the web server and the database.
I think you should just give up, Moon. You're not doing very well. So we're going to use WAF again to help us with this particular attack, and we already have WAF deployed on CloudFront, so we can continue using that. All we need to do is add rules that will be focusing on SQL injection. And if we know that the attack is going to be coming in only through a query string, so that's the only time we expect some potential SQL injection to come in through, we can set up a rule that will look at all of the query strings from all of the requests and then identify if there's SQL injection in that query string. We can do some transformation, so we can lowercase URL decode and then set up the level of confidence that we have that this is actually an SQL injection attack, and then take an action, in this example, just blocking that traffic. Now, if we're protecting more applications, we can also use a manage SQL injection rule that already provides you with a set of rules for all sorts of different potential entrance avenues. So maybe the SQL injection could be coming in the body of the request for some applications, and some could be coming in through a cookie. But if it's query string arguments, then we have a rule for that as well, and we can just block that traffic.
Okay, so the availability types of attacks didn't work, so now I'm going to go for the crown jewels and try to get there by account takeover. And what I mean by this is that I'm going to get compromised credentials that I can see on the dark web, and my goal is that folks in the organization are now using these credentials to authenticate to a number of different services within the organization. So with that, I will try to gain access, and a successful login means that I was able to utilize those stolen credentials.
All right. So the good news is WAF can also help us here. So this time, we're going to set up rules that are specific to account takeover prevention to stop Moon from trying out all those different accounts that he bought on the dark web. We do have to specify the path that the WAF needs to look at. We do need to specify how the credentials are coming in. If it's JSON or is it a form encoded. And then specify where is the username, where is the password, so which fields are we going to have to focus on. And then finally take an action as to what do we want to do with the traffic if we detect compromised credentials. Now, from a WAF perspective, it's going to be always a cycle. So we start off with creating a web ACL. Maybe it's initially going to be in the count mode. And then we start monitoring and logging and seeing what are we getting, are there any false positives, false negatives, and then making adjustments, making modifications to decide what we're going to do with the traffic, and then go back to updating and creating our ACLs. And I want to leave you here with some DDoS protection best practices, because we did touch on DDoS. But again, it's not just using Shield, it's not just using WAF, it's also doing well-architected deployments with your architectures to make sure that you can accommodate those initial spikes of traffic when we're seeing DDoS traffic. Okay. So the next question is to WAF or not to WAF. So far we were talking about a HTTP application or HTTPS application. And our recommendation is if your application is HTTPS, use WAF. However, there might be scenarios where you have non-HTTP applications or scenarios where you want to use different type of solution for protecting your ingress applications. So option number one could be using a third-party vendor. So this could be your favorite appliance that you have on premise and bringing it into AWS as an EC2 instance and deploying it usually behind the gateway load balancer, which is our load balancer service that allows you to scale these appliances in the cloud. And then what filtering capabilities you have, maybe also WAF capabilities, will depend on what kind of vendor you're going to go for. So here is the non-exclusive list of some of the gateway load balancer partners and vendors. So I often see customers taking a decision to bring a third party in when they already have someone on premise, that the security team is familiar with how to configure a particular vendor, and it's just initially easier to bring that vendor into AWS to apply the same policies and the same security in AWS. Now, if you don't want to manage the gateway load balancer or the third-party vendor appliances, or the patching, scaling, and so on, you can go for a managed next-generation firewall from AWS Network Firewall. Allows for TLS decryption, as well as deep packet inspection, capable of inspecting any TCP and UDP application. But again, if your application is HTTPS, you really want to go with WAF. Network firewall, we're not covering it today, but network firewall also is a really good idea for your egress filtering, but that's a story for another session. So let's talk about how you actually deploy these different components into your architecture to protect your ingress traffic to your applications. So Moon has already showed you this diagram. So this is our internet connecting to a load balancer. We're going to shuffle things around a little bit for better visibility, where we will have two AZs. Subnet 1 is an AZ1, subnet 2 is an AZ2, and so on. And then we have a load balancer in the middle connecting to some backend instances or Lambda functions. And then to add inspection before traffic hits our load balancer, if we're bringing a third-party appliance, we would deploy gateway load balancer endpoints in subnet 1 and subnet 2. And those gateway load balancer endpoints are effectively an extension of a gateway load balancer that could live in the same VPC, but I like to put it in a separate VPC because it just makes for a cleaner architecture. But it's up to you which way you go. From a cost point of view, there's no difference. And then the gateway load balancer points to a set of third-party firewall appliances. And it's the responsibility of the gateway load balancer to keep track of all the sessions and make sure that traffic is symmetric and flows in each direction will land on the same firewall appliance. Otherwise, traffic would get dropped. So the way to get traffic to those third-party firewalls, it's not as easy as it was with web application firewall, where it was part of the load balancer. You have to set up your routing configuration to effectively route traffic to your firewalling layer. So you have to set up an ingress route. That's a new type of route that's associated with the internet gateway. And that ingress route we have here will just intercept any traffic that goes to the load balancer and push it through these gateway load balancer endpoints in respective availability zones. We also have to configure return routing to make sure traffic is symmetric. So when the load balancer responds back to the internet, traffic is to go back through the respective gateway load balancer endpoints. And then we have to have a route from that subnet to send traffic back out. So this is the routing. But just know that I'm showing you a gateway load balancer with gateway load balancer endpoint, the third-party appliance. Under the hood, the managed offering AWS Network Firewall also uses a gateway load balancer. You just don't have to manage it. So any network integrations you'll see are interchangeable. So everywhere you see AWS Network Firewall endpoint, you could put a gateway load balancer endpoint, and vice versa. Everywhere you see a gateway load balancer endpoint, you can put a network firewall. So it's up to you which one you select. I'm not going to show you both because that would be redundant. Just know they're interchangeable. So for this use case, we're going to continue with the gateway load balancer because I want to show you how exactly the flow looks like. Here we have an encrypted flow coming in. So the red line is encryption, inside is our traffic. Traffic will come in through the internet gateway, and then the route will redirect the traffic to the gateway load balancer endpoint and effectively to gateway load balancer. And finally, the gateway load balancer will pick one of the appliances to handle the flow. Now, if we have a certificate for the application, the third-party appliance could do TLS decryption, inspect the traffic, re-encrypt, and then send it back on its way to the actual load balancer. So you've noticed that the traffic took a little detour. We call it the bump in the wire. No NATing, no IP addresses were changed. It's just raw traffic passing through, getting inspected, and if it is allowed, it's getting to the load balancer. Load balancer would usually do TLS termination as well, if that's what you configured and that's the load balancer you're using, and then send it back on its way to one of the targets. Return traffic, same exact way, just in the opposite direction, so I'm not going to show you that. Now, there's another option with deploying third-party firewalls as well as network firewall into your architecture for ingress, and that's to put your firewalling layer after the load balancer. So far I've showed you the one where load balancer is below the firewall when traffic comes in from the internet. Now we're switching it up. So here we have a load balancer targeting some EC2 instances. Just note that if you're using a network load balancer has this magical function that allows you to preserve the real client IP address all the way to the target. So we're doing some software-defined magic to make that work. Now, what this means is you can't really do client IP preservation and NLB and put the firewall in this scenario like I'm going to show you in a second. So just be aware of that. Okay, so now we're deploying gateway load balancer endpoints in subnets 3 and 4. And the next thing we need to do is configure the routing. So we no longer need an ingress route because traffic is not coming through the internet gateway to the load balancer, to the gateway load balancer. But we need more specific routes in subnet 1 and subnet 2. So in subnet 1, we need a route up to the internet, which is normal. But we also need a route back to the EC2 instances in subnet 5 and subnet 6. And we want to force that traffic to go through our gateway load balancer layer, so effectively a firewalling layer. And we would have to do the same thing for subnet 2 and decide which gateway load balancer endpoint we want to use for which AZ. And then finally, we want to make sure that the return traffic is using the same gateway load balancer endpoint. So I see a lot of customers sometimes make mistakes with the routing layer and messing up one or two routes, and then connectivity might not work. But the good news is that's something that you configure only once, and if you do it once and it works, then it's done. You don't have to go back and modify it anymore. Okay, so let's have a look at how a packet flows through this setup. So first of all, it gets to application load balancer or network load balancer. TLS gets terminated. Traffic gets re-encrypted, and then we're sending it on its way to the target, but the more specific route redirects the traffic to the gateway load balancer endpoint and finally to one of our firewall appliances. We can do decryption again, inspect the traffic, decide what to do with it, and then send it on its way to the actual target. In reverse, same exact story. Okay, so now we've introduced those two different options where we have the firewalling layer between the internet gateway and the load balancer on the left, and we have the firewalling layer below the load balancer and the targets. So what are the pros and cons of these two approaches? So the ingress routing model, the firewall will see all traffic. So that means it will see the traffic that's legitimate, but it will also see the traffic that's DDoS. Right? So if our application is 443, and we start seeing UDP flat to our application, the firewall layer is going to have to scale. And you're responsible for that scaling. So if you have two Palo Alto appliances and you haven't accounted for them having to scale, you've got to add additional appliances or set up auto-scaling somehow. However, the good news is the firewall can see the real client IP address in the packet. Right? There's no NATing happening on the way in. We just see the public IP address of the client. So the firewall can take an action based on the real client IP address. And then firewall, because it's above the load balancer, it will need public-facing certificates. So it needs access to that public-facing certificate. So if you are using things like AWS Certificate Manager, then you need to consider that you can't really export certificates originating in Certificate Manager. You can only import. On the other hand, with the more specific routing option, the firewall will only see the traffic that has already been accepted by the load balancer. So if the load balancer was listening on port 443, firewall will only see traffic on port 443. So it doesn't have to scale as much. It usually will see mostly legitimate traffic. However, the policies that you're configuring can't be based on the real client IP address because that will be NATed to the IP address of the load balancer. So now all the traffic from a packet point of view comes from the Elastic Load Balancer, not from the public client out on the internet. If it's an ALB you're using, you can include the IP address in the X-forwarded-for header and then have your firewall take a decision on that. But if you're using an ALB, you might as well just use WAF. Finally, the firewall doesn't need to have the public certificate, right? It's sitting behind the load balancer, so after the public certificate was presented to the client. So it means that you could put a private certificate on it and still be able to decrypt the traffic. Or I've seen some customers even not encrypt the traffic, although we wouldn't recommend that. And just like I called out before, that setup with Elastic Load Balancer being an NLB and client IP preservation unfortunately doesn't work there. So you can't use more specific routing if you have an NLB and you want to do client IP preservation. Okay, talking about client IP preservation, there's another use case I want to touch on that comes up a lot with customers, specifically those customers who use Global Accelerator. And Moon already touched on Global Accelerator. It's effectively a global network of edges that allows you to bring TCP and UDP traffic onto AWS backbone and then globally load balance that traffic between different regions and different resources in AWS. Now, for this specific example, I'm only focusing on a single VPC, and we'll talk about adding inspection to traffic coming in through Global Accelerator. So you can set up Global Accelerator in two modes. You can enable client IP preservation, or you can disable client IP preservation. So in this first example, there is no client IP preservation. We have some user with a public IP address that will connect to our service. So Global Accelerator, which also can have Shield enabled on it, will accept the traffic, will represent our application. So that could be a TCP connection on some arbitrary port, or it could be a UDP flow. And we're hitting the Global Accelerator. There's no IP preservation, so Global Accelerator will NAT the client to its own IP address. So from a perspective of this network load balancer, we'll see the traffic coming in from Global Accelerator. And if this is not HTTP traffic, there's no way to actually see what the real client IP is. But the good news is it's very easy to add inspection to this layer. Just like we talked about before, we can add a network firewall or we can add a gateway load balancer endpoint in the path between the internet gateway and the network load balancer using the ingress routing option. Okay, so let's talk about when you enable client IP preservation. So client IP preservation, when you enable it on the Global Accelerator, actually does something cool. It creates network interfaces inside of your VPC that will be used to bring the traffic in from the client. And when the client connects, with this configuration, AGA or Global Accelerator can transport the traffic all the way privately to the load balancer. And if the load balancer is a network load balancer and it also has IP preservation enabled, we're actually getting that real client IP preserved all the way to our instances on the backend. Now, from a filtering point of view, how do we protect this traffic? So to configure AGA with network load balancer, we have to set up security groups on network load balancer. So that could be one option where we're setting up rules through security groups to limit where the traffic can come from. But what if we want to do firewalling? So we can't really put a firewall or firewalling stack in between the Global Accelerator ENI and the network load balancer because they're in the same subnet. We know we can't have a firewall between the network load balancer and the backend instances when client IP preservation is enabled on network load balancer. So what can we do? The only option is to bring third-party firewalls and make them the target of your first network load balancer. That way, the third-party firewalls will see the real client IP address and will be able to make a decision on the IP address if that's what you need to do. And then from there, those third-party firewalls would be forwarding the traffic to the next layer of your load balancer and actual backend targets. Okay. So far, we talked only about a single VPC, but I don't know of a single customer who only has a single VPC. We all have multiple VPCs. So what do we do if we want to do ingress filtering with multiple VPCs? And there's two approaches that I've seen customers take, specific to their data plane. So very often, this is a discussion we're having. Should I centralize or should I decentralize my data plane? So one option is distributed ingress, which means I have 100 VPCs. Each VPC has an internet gateway, and each VPC has some load balancer exposed to the internet. The centralized ingress option is I have one VPC with an internet gateway. Everything aggregates, and then I have to find a way to send the traffic out to all the other application VPCs, but they don't have their own internet gateways. Now, one thing that you need to be aware of is you must proxy the traffic somehow in that initial ingress VPC, and then you need to figure out a way of how you connect from that central ingress VPC to other VPCs at the bottom. And usually you'll have to have something like a network load balancer representing your service because you will need to target a static IP address. Now, if we zoom into that ingress VPC, you're already familiar with what that is and how that looks like. We saw that earlier. We had the targets, we had the ingress route table, we had the gateway load balancer endpoint at the time, now it's a network firewall, then a load balancer, and we were targeting things in that VPC. In the scenario of the centralized ingress, we will be targeting things in those other application VPCs. So the load balancer in the central ingress VPC targets usually a network load balancer in the bottom application VPCs. And I'm showing you a transit gateway, but you can also find different mechanisms in which you will connect that ingress VPC and your bottom VPC. So you could be using AWS Cloud One. You could be using AWS Private Link. So it's up to you to decide which option you want to go for. Now, so should you or should you not centralize the data plane? So the only pro, or the biggest pro, is makes it a little bit easier to govern. Right? If I know that I only have one VPC with one internet gateway that everything comes in through, it might be easier for me to know that I can put all of my security solutions or security control points into that VPC, and then I know nobody else has access to and from the internet. But there's a lot of cons on that approach. So if you are going with centralized ingress, just be aware that there's downsides. You're increasing your blast radius. Right? If something goes wrong with that one central VPC, all the applications are going to have a bad day. You're increasing complexity. Right? So I like to think about this 3 a.m. test. If you have an engineer that can wake up at 3 a.m. and see what's going on, like the more components you add to your architecture, it makes it more complex for someone to figure out what's going on, what's sending traffic to where. Plus, every time you're exposing a new application to the internet, some team that manages that central VPC is going to have to update configuration in there to decide how the traffic should flow. And finally, there's going to be increased cost. Right? You're having to jump over different components, different load balancers, transit gateway, Cloud One, whatever that is. There's cost associated with traversing all these components, both financial as well as a little bit of extra latency for your traffic. So often when customers say, I want to centralize my data plane, what they actually want to do is centralize their control plane. So have a way to have a distributed layer of internet gateways and VPCs, but have the ability to centrally control the policies that are deployed across all of those different VPCs. And if that's what you want, you can use AWS Firewall Manager, which is the central way to control security policies within your organization across a number of different services. So we saw WAF, you can use it for Shield. Recently we added even network access control lists, security groups, network firewall, DNS firewall. There's components that we haven't talked about. And we also have partner solutions. So two partners, Palo Alto and Fortinet, have managed firewall offerings where they managed the gateway load balancer for you and the appliances for you. So it's closer to the network firewall model. And you can manage those also through the Firewall Manager. And then any issues, any challenges that the Firewall Manager detects, you can send notifications to Security Hub, but you can also take actions. So let's look at an example. Here we have a policy within Firewall Manager where we want to push a specific web application firewall policy onto different CloudFront distributions. So we have WAF already deployed in CloudFront across different accounts in our organization. And we just want to make sure that the policy is the same one that we've created in a central account. So here what I'm saying is I'm including all the accounts. I want to check all the accounts in my organization. I'm only caring about the CloudFront distributions. The resources I want to apply the policy on are only the resources with a specific tag. So I'm only interested in environment production. I don't care if someone has a dev CloudFront distribution and they don't have the right policy on it. And then I can take an action. So I can identify that things are out of policy, and then alert my security team. They can chase whoever has an issue and force them to update. Or once I feel more comfortable, I can also auto-remediate. So I could have Firewall Manager go out and make those changes for me and update the policies to match what I want exactly. Okay. So to close off, if you want to get deeper in some of the concepts we talked about and some of the security solution, you can check out our network and application protection site. We also have a number of security workshops that you can get access, as well as join our security activation days for a guided session with solution architects. So with that, Moon and I want to thank you for joining. If you have any questions, come and chat with us afterwards. Yeah, and have a good rest of Reinforce.